The Pythagorean Theorem, or the Pythagoras Theorem, as some people call it, is one of the most important concepts in all of mathematics. It deals with right triangles. It deals with right triangles. A right triangle has three sides, and one side of the right triangles that is without question always called the same thing is the hypotenuse. You will learn more when you get into trigonometry why sometimes one of the sides is called the opposite and the other side is called the adjacent, or the other way around called the adjacent or the opposite, because it depends on what the angle of in question is. But that's not today's topic. Today's topic is dealing more with just the sides. So let's remove these over here, and we're going to instead just say legs. Legs, yes, two legs and a hypotenuse. The hypotenuse is across from the angle 90-degree mark right there. So when the Pythagoras theorem is very fascinating, has a lot of applications in the real world. But there's a little bit of history here. They tell you about a Greek mathematician and philosopher born on the island of Samos. His name was Pythagoras. He founded a number of schools, one in particular in a town of a southern, one in particular in a town in southern Italy called Crotone, is the way I would pronounce it, whose members eventually became known as Pythagoreans. The inner circle of the school, they had a name, they lived at the school, and they had some interesting beliefs. But they studied mathematics, philosophy, and music, and from my understanding, I've heard that there was just some weird stuff that and I mean here they talk about they getting rid of personal possessions. They were vegetarians. They observed a strict vow of silence. So it's kind of interesting to learn about the history behind some of the people who were doing the math. Now, don't worry, you do your math, you do your best, and you don't have to worry about joining a group of people that will get rid of all their possessions and so on. You just do your math and you do well. But it's just interesting to read their history. So there's other mathematicians that were different from the Pythagoreans, so keep that in mind. Today, nothing is known of Pythagoras's writings, perhaps due to the secrecy and silence of their society. However, one of the most famous theorems in all of mathematics does bear his name. Prior to revealing the contents of the theorem, we need to pause and provide the definition of a right triangle, which is what I've shared with you already. We can call the sides, each of the legs, A and B, and the hypotenuse we can call C. That's one way that we do this in explaining the Pythagoras theorem. With the Pythagoras theorem, we basically say that the sum of the squares of the two legs is equal to the square of the hypotenuse. So that's an important thing to keep in mind. So we use this principle for problems involving right triangles. So if you have a right triangle and I tell you that this leg is 6 and this one is 8, find this one. Well, you would just say 6 squared plus 8 squared, and that will give you the answer that you're looking for. So this would be 36 plus 64, which is 100, or 10 squared actually. So that is one way we see the Pythagoras theorem at work. There is something called the Pythagoras Triples, which just tells you numbers that if you were to square the first one plus the second one, it would give you the third one. And this is another example of a triple. So there's many examples of triples actually. And this is just giving you some examples. So the hypotenuse, if they give you the hypotenuse and you have to look for a side, it gets interesting. So let's look at one situation. So if you have the hypotenuse, right? So let's say the hypotenuse is 25 and one of the legs is 24 and you don't know what this is. Then it becomes x squared plus 24 squared is equal to 25 squared. So do you see what I did? Using the same formula of a squared, right? Imagine if you had a squared plus b squared is equal to c squared. A in this case is actually x, b is 24, and c is 25. And I've plugged them into this equation here. So basically we have x squared plus 24 squared plus 25 squared. Is equal to 25 squared. So let's look at 24 squared, 576. So we have x squared plus 576 is equal to 625. So if we subtract 576 from both sides, then we actually end up with x squared is equal to 49. So x is equal to 7. So this value is actually 7 because 7 squared plus 24 squared will equal 25 squared. So that's how the Pythagoras theorem works. I'll provide you with another example in a different video, but that's what the main focus is for this chapter. If they ask you to round up, use the test digit and use the same principle, because sometimes when you take the square root of a number, you might not get a perfect number. So let me give you a note here from the last page of the section, or second to last, page 441. It says a 15-foot ladder leans against a wall on a building. So if a ladder is leaning against a wall on a building, right? If this is the wall and you have a ladder, and they ask, the base of the ladder lies 5 feet from the base of the wall. So 5 feet from the base of the wall. How high up the wall does the top of the ladder reach? Round your answer to the nearest tenth of a foot. So basically, we need to know how high up the ladder reaches here. So remember, if this is A and this is B and this is C, A squared plus B squared is equal to C squared. A squared plus 5 squared is equal to 15 squared. A squared plus 25 is equal to 225. And then we subtract 25 from both sides. So A squared is equal to 200. Now we take the square root of 200. What is the square root of 200, right? It's not a perfect square. So if you have the square root of 200, you would notice that the answer is 14.142, and then it goes on for a while. But they wanted you to give it to the nearest tenth, so that would just be 14. They wanted it to just the tenth, so you would just say the answer is 14.1. Why? Because the test digit is 4, which is less than 5, so it's just 14.1 for this particular problem. So with the Pythagoras theorem, a squared plus b squared is equal to c squared. We write down that relationship. We write down what a is and what b is and what c is. And we work our way to the end of the problem. Let me know if you have any questions. This is a very important topic, so if you need more examples, let me know. Thank you, and we'll see you in the next video.